Happy day, everyone. This is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. Please, before we go into today's topic, do not forget to like, share, subscribe, and click on the notification button to have more of my video. Today, we are taking a topic in mathematics, and that topic is called matrices. This is the plural form of matrices. So the singular form of it is called matrix. So this is the singular form of matrix. Now, for us to have a real life understanding of what matrix may stand for, I want to make use of the family table. Now, let's say we have this family table. And then the foodstuff that the family is having. Let's say I'm having a family 1, family 2, family 3, and then the foodstuff the family has in kilogram. I have rice for each of the family, then beans, and then yam. Let's say all these food, they are in kilogram. So for family 1, let's assume that family 1 has 2 kilograms of rice. I'll write 2. If the family 1 doesn't have beans, it will be 0 kilogram. Now for family 1, if the family 1 has 1 kilogram of yam, I'll just write 1. Family 2, let's say it has 3 kilogram of rice, 1 kilogram of beans, 0 kilogram of yam. Then family 3, let's say it has 1 kilogram of rice, 2 kilogram of beans, and 3 kilogram of yam. I can represent this one in a summary version called matrix. So let's say matrix M. Instead of me putting all the information on the table, I'll just write the value of the kilogram of food that they have. So I will just put the values alone: 2, 3, 1, 0, 1, 2, 1, 0, 3. Each of the entry inside this bracket is called elements of the matrix. Elements. Each entry there is called elements, and every element has address. I will show it now. Every element has what is called address. The address is to indicate the location of a particular entry in a matrix. So let me put the matrix M back again here. We have 2, 3, 1, 0, 1, 2, 1, 0, 3. Now, when I'm taking the value horizontally, then I'm referring to the rows. When I'm taking the values vertically, I'm referring to what is called column. So, for instance, let me take this particular entry. We know that this entry is in row 1. That 2 is in row 1 and column 1. So I will write it as 2 in row 1, column 1, which can be written as 2, 1, 1. If I take this particular entry here, you know the entry is in row 3, column 3. So this 3 is in row 3, column 3, can be written as, that's the address. If I'm taking this particular element here, the element is in row 3. So I'll write 3 there. But when I take it vertically, is in column 1. So that particular element, the address is 1 subscript 3 1. That's how to obtain address. Now let me indicate it again. Let's say I have this matrix. If I have this row 1 2 3, these are called the rows. If I take vertical line like this, these are called the column. Now the point of intersection of the rows and column will be the location of the elements of the matrix. So this matrix M, now I can put this element there. For the first one, let me put each of the dots, let me return with just ordinary A originally. Then I have another A, then the last A. Now we can see these are the column. The vertical lines are the column. The horizontal line are the rows. We normally write rows before we write column. Now let's start with the first element on top here. It's in the first. All the elements on top here, they are in the first row. So I'll just write A subscript 1 1. And each of these elements, the first one is in column 1, the second one is in column 2, the next one is in column 3. So A subscript 1 1, A subscript 1 2 that I have here, and A subscript 1 3 are called the address of each of these elements. Now if I move to the next row, this will be second row. I'll write 2 2 2, and then the first element in the second row is in column 1. I'll write 1. The next one is in column 2, the next one is in column 3. So all this one gives the address of the element. Then when I look at the third row, I'll write 3 3 3 under each of the elements, and the first one there is in a first column. I'll write 3 1. The second one is in the second column. I'll write A subscript 3 2. Then the third one is in third column. I'll write A subscript 3 3. Now let's do this example. We are given this matrix M. Let's say we have -1 0 2 3 4 and 5, and the question say find address of 0. Now how do we do it? What we are going to do is to find the location of this 0 horizontally and vertically. Now this 0 is on this horizontal line and is on this vertical line. The horizontal line I wrote there is R1, but it's located on the second vertical line, so I'll write it as C2. So element 0 is in row 1 and column 2. So I'll write it as 0, that's 1 2. Now let's do another example. Let's say I have matrix A is equal to 1 4 3 0 7 1 8 9 and 10, and the question says we should find this particular element, the address of it. Now for us to find the address of this element, we first of all draw horizontal line, and this horizontal line is on the second row, so you write it as R1, and we draw this vertical line. This vertical line is on the third column. I'll write the C2. So element 1, this particular element 1 is in second row, sorry, is in row 2. So I write it as a row 2 and is in the column 3. So I'll write it as a 1 subscript 2 3. So that's how to get the address of a matrix. Now, what is a matrix? Matrix M is defined as rectangular array of elements. These elements can also be called members or numbers. In rows and columns enclosed in a bracket. So this is just a simple definition of a matrix. Now, the next thing we are going to discuss is the order of a matrix. Order of a matrix. How do you find the orders of a matrix? Order is the number of rows and columns of a given matrix. Like for instance, let's say I have this particular matrix A. Now, if I want to find the order, I'll first of all find the number of rows. I'm talking about the horizontal lines, then the vertical line, the number of rows and the number of columns. Like for instance, now this is the first row, row 1, row 2. So it's going to be 2 by, we normally write row by column. So the number of rows here are 2. The columns, the vertical line, 1, 2, 3. So it's going to be 2 by 3. So the order of this matrix is order 2 by 3. Let's try another one. Let's say we have matrix B. I have this -1, 0, 2, 4, 6, 10, 8, 9, 7. We are asked to find the order. So the order is the number of row by the number of column. Look at this. The rows are the horizontal lines and the columns are the vertical line. So before of all, count how many rows. So you count row 1, row 2, row 3. So we write 3 by, then the column 1, column 2, column 3. That is 3 by 3. That is an order 3 by 3 matrix. Now let's try another one, matrix C. Let's say we have 0, -1, 5. How do we find the order? To find the order is simplifies the number of rows by the number of column. We have only one row. Then the number of column 1, 2, 3. So is a 1 by 3 matrix. Is 1 by 3 matrix. So that's that. Now let's try another one. Let's say I have matrix Z, then I have something like 0, 5, -1. Now we want to find the order. The order, like I said, is a number of rows by number of column. So this is the row 1, row 2, row 3. So I'll write 3 by, then it has only one column, 3 by 1 matrix. So now, if the question says give an example of a 3 by 2 matrix, this is one way that I would love us to do it. by solution, the first number here is for the rows and the second number here is for the column. So we are talking about 3 rows, 1 2 3, and 2 columns, 1 2. So the element will be located at the point of intersection of the 2 lines. So in this case now, I will put my elements A, 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 A. So the first elements that are in the first row, I'll write it as 1 1, and the second row will be 2 2, the third row will be 3 3, and then for the columns, this one are in the first column, 1 1 1, this one are in the second column, that is a 2 2 and 2. So another way to write this, instead of using the elements with the address as that I've indicated, I can just use any letter. Like this one, I can write letter A, B, C, D, E, and F, and write the matrix in this format: A, B, C, D, E, F. That is an example of 3 by 2 matrix. Another one, give example of 4 by 1 matrix. So by solution, this is row by column. That means 4 rows. So you draw 4 horizontal lines, 1 2 3 4, and the column is 1. So the elements they are located at the point of intersections of the horizontal lines and the vertical line. So I can write this as A, B, C, D. So the matrix is actually A, B, C, D. So I can write it as matrix A is equal to this. And since we are having just a column, this is an example of what is called column matrix. Column matrix. Since we are having just one column. Now look at a similar example. Give example of 1 by 4 matrix. So you write row by column. That is a 1 row 4 column. So 1 row means you draw only 1 line. 4 columns mean you draw 1 2 3 4. So the elements will be located at the point of intersection of the horizontal line and the vertical line. So you can put any letter. Let's say letter A, B, C, D. So let's say it's going to be matrix B, A, B, C, D. So this is the one example of 1 by 4. Since we are having just a row, this is called a row matrix. A row matrix. So before I continue in my next lesson on this topic, I want to introduce us to what is called the trace. The trace of a matrix. The trace of a matrix. For a rectangular square matrix, square matrix A. Let's say we have this matrix. We have A, B, C, D. To find the trace, just add the elements along the diagonal here. So trace T is going to be A plus D. For instance, let's say we have matrix A to be given as -1 4, minus 7 6, and we have to find the trace. To find the trace is simply add the number along the diagonal that I've indicated. This particular diagonal is called the leading diagonal. So it's going to be minus 1 plus 6, which is equal to 5. Now, look at this square matrix. Let's say matrix B. We are having it as 3 1 4 minus 1 minus 1 0 4 7 8, and the question says find the trace of this matrix. To find the trace, just look at the elements along this diagonal, the one I've just picked here. So the trace T is going to be 3 plus minus 1 then plus 8, which is 3 minus 1 plus 8. 3 minus 1 is 2. 2 plus 8 will give us 10. That's how to find the trace of the matrix. So in my next video, I'm going to introduce us to the idea of what is called a minor of a matrix and the cofactors of a matrix, how to find the minor and how to find the cofactor. Then the subsequent video will also dwell on how to find the determinant of a matrix and how to use this information to find what is called the inverse of a matrix, the idea of the cofactors too, what is called the adjuncts of a matrix, and how to use this information to solve linear simultaneous equation in a given number of variable. Thank you for watching. This is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube.